Hi folks, today we're going to be factoring polynomials. Now factoring is no different than the factoring that you've seen in the past. The only real difference is these are bigger. So there's going to be a little more forethought that needs to go into this in terms of, what can we take out of these to make our factoring easier. So we always want to take a look and see, is there anything that we can pull out of all of our terms. So here the coefficients for both of these are divisible by 2. So we can pull a 2 out right away. And if we also look at our exponents, we have 5y's here, we have 3y's here, so we can take 3y's out of everything. Now, the question is what's left? So it's a matter of kind of that opposite of distributive property, or the opposite of FOILing. 2y cubed times what would give us 2y to the fifth? And the answer to that would be y to the second. Minus 2y cubed times what would give us 18y cubed? And the answer to that would be 9. So we've started our factoring. Now we need to see if we can continue with it. And you need to be able to recognize certain things, like this would be the difference of 2 squares. We can take difference of 2 squares further. So taking that difference of 2 squares further, we would still have the 2y to the third. And difference of 2 squares will be automatically plus minus. That y squared breaks up into y and y. And then the 9 would break up into 3 and 3. So now we have factored completely. The next one, 4z to the fourth minus 16z to the third plus 16z squared. Again, we want to focus first on those coefficients, 4, 16, and 16. We know that they're all divisible by 4, so we can take a 4 out of all that. Now we look at the variables, z to the fourth, z to the third, z to the second. So we can pull a z to the second out of everything, and that's as high as we can go. So now, what's left? So 4z to the second times what would give us z to the fourth? All right, so that'll be z squared. Minus, same type of thing here, 4z squared times, in this case it'll be 4z, plus, and over here it'll just be 4. Now again, factor completely. So we take a look here. We can factor that further. So we have 4z squared times. Now we know minus plus, so our binomials will be minus minus. The z squared breaks up into z and z. And our factors of 4 are either 1 and 4 or 2 and 2, but having a 2 and a 2 will give us the right factoring. So now, since we have the exact same thing twice, we want to make sure that we get into the habit of writing it like this. So 4z squared times z minus 2 quantity squared, because there's 2 of them. And there it is. On these next couple, I would like to leave this one blank for you, and I want you to try and figure it out. I'm going to give you a hint that it is difference of 2 squares the whole way through. So you're going to wind up doing difference of 2 squares 2 times on this in order to get it factored completely. I want to focus on this one over here now. Again, we're looking at coefficients first, 4, 20, and 24. So those are all divisible by 4. And then t to the 6th, t to the 4th, and t to the 2nd. I know I can get a t to the 2nd out of that. So what's left? So first off, we're going to have a t to the 4th left. Minus 5t to the 2nd plus 6. So now on this, I need to be able to factor this further. And I can. I can take this a step further. So the 4t squared is still there. It's still factored out. The minus plus, I know I can break that up into minus minus. Now things get a little bit different than what you're accustomed to seeing. This t to the 4th, if I look at this middle term here, notice it's a t squared. So I can break this t to the 4th up into t squared and t squared. And then the 6, I can break that up into either 1 and 6 or 2 and 3. whichever is going to give me this middle term of minus 5. And in this case, it would be 2 and 3. So now I need to make sure I check these out. Are these difference of 2 squares, yes or no? And in this case, no, because the 2 and the 3, neither one of those are perfect squares, so there it has been factored completely. The last thing I want to show you is factoring by grouping, and this works when you have 4 terms, like these couple of problems are. And to factor by grouping, typically what you're going to want to do to start out is just break it up, first 2, second 2. Now, in that first 2, is there anything I can pull out of that? And I can pull an x squared out. And then what's left is x minus 3. Now, the trick comes in this next part. I can pull something out of that, but when I pull out of that, when I factor out, I need to have x minus 3 in there as well. I need to have these 2 sets of parentheses be the exact same. And the number that pulls out would be minus 16. A negative 16 factors out to leave that x minus 3. So now, what happens when you factor by grouping is you have that same thing, that x minus 3 goes in one set of parentheses. And the x squared minus 16 would go in the other set. All right, it's not magic. It's not an x minus 3 squared. It's just x minus 3. And I can talk about that in class. But this is now on the road to being factored. Again, we need to look, is this difference of 2 squares? Can I take it further? The answer is yes. It's difference of 2 squares. So that x minus 3 is still there. Here we have difference of 2 squares, so it's automatic plus minus. The x squared is x and x, and the 16 breaks up into 4 and 4. So now it is factored completely. All right, over here, we can factor by grouping again. And this one, I want you to try it on your own. Use this first one as kind of your template to go by. But as you factor this out, the complete factorization for this one should be x plus 7, x plus 3, and x minus 3. So go ahead and try that one on your own, and we'll talk about it if we need to. Just so you're aware that this factoring is going to be a big part of what we do going forward. So this is something that you have to get nailed down and know how to do. All right, so please practice this on page 356, numbers 3 through 8, 18 through 29, and we'll see you in class.